In this video, I'm going to introduce you to testing with JUnit. We can conduct our tests manually, and that might involve, as we have done so far in Spring Boot, listing a number of requests that contain the input data for our tests, and then one by one we run them and read the result. And then we have to answer this question: is this result right or wrong? Is it what we expected? Now, when you've got 5 or 6 tests, that probably isn't a problem. But if you've got a big system, and most enterprise applications are very big, then the number of tests will be very large as well. And so to test all of that manually, checking each one to make sure it's right or wrong, is going to be a very long, tedious process. And so we get some problems with manual testing. We might type the request incorrectly. We might send different data on different tests of the same endpoint, which means we end up with inconsistent testing, and that's not a good thing. We might have to use the live system, also not a good idea. And then we have to manually check the results, and that is going to be very prone to errors. And so we can't really have full confidence in the manual testing process. If we were to automate the testing process, we would have a lot of benefits. The first is it's very easy to see whether tests pass or fail. As you can see from these 2 screenshots, when we run the tests, we get a very clear notification to tell us whether the tests have passed or failed, and if so, how many have failed, along with a list so that we can click on the ones that haven't passed and get to see the reasons why. It also means that we can run lots of tests very quickly with the same test data in the same way every single time, and that gives us consistent testing, and that's really beneficial. The checking of the results is done automatically, which means we never have to read a lot and therefore much less likely to get it wrong. Even with hundreds of tests, this automated process is very fast, it's never tedious, unless of course you don't like writing tests. And it's almost always a very good idea. When you're dealing with enterprise applications, which are very big and very complex, automated testing is essential. Inevitably, during the lifetime of the enterprise application, you will have to make changes. When you do that, you should run the automated tests before making any changes, and then run the tests again after making the changes, just to make sure that you haven't broken anything. And it's not just the class that you're working on that you should check, but you need to run the whole suite of tests for the entire application. Because if you make a mistake in the one class that you're changing, that might have some knock-on effect elsewhere in the application. Using automated testing will make the running of all the tests for the entire application much easier to do. Of course, where possible, we try not to change a class after it has been deployed to the live system, and we'll talk more about this in a later learning block. Automated testing is usually done via a test framework. Most programming languages have got at least one test framework available, and in Java there are many. 2 of the most popular are JUnit and TestNG, and we're going to focus on JUnit. In JUnit, we develop test suites. A test suite has 1 or more test classes. A test class has got 1 or more test methods, and a test method will set up the little universe for that test, perform an action, and then check the result of the action. And the test will pass if the result is exactly as we expect, otherwise it will fail. In the JUnit framework, when we run the tests, the framework will execute all the tests, and the thing we've got to watch out for is that there is no guarantee about the order in which those tests will run. And that's why we've got to make sure that each test is independent of all the other tests. And that's why we talk here about each test having its own little universe. It should depend on nothing that is outside of the test itself. A JUnit test class is a standard Java class and has some annotations. For example, each test method will be annotated with @test, and that tells the testing framework that it has to execute this method as a test. One of the things that we need to be careful about is the name of the test method. Now you'll notice from this example here that the method names are very long. That is not a problem. In fact, the clearer the intent of the test, the better, and the name of the method will convey that intent. There are different conventions for naming our methods, and I've used here the when expect convention. So when some condition, we expect some result. In a test method, we can use assertions to verify the truth of conditions. If an assertion is incorrect, the test immediately fails, and the test will only pass if all its assertions are correct. Now in JUnit, there are a lot of assertion methods, a few of which are these. We're going to assert equals, and this method will look at the expected object and the actual object. It will call the equals method on those objects, and if that returns true, this method will pass, and if the objects are not equal, this assertion will fail. Assert true and assert false will look at some Boolean expression, and if it is true, this assertion passes, but if it's true, that assertion fails. So we just need to pick the correct one that we're wanting to verify. We can do something similar with object references. We can assert if that object reference is null or not null, and again the assertion will either pass or fail, and that will determine the outcome of the test. Sometimes we expect an exception as the correct result of a test, and we can assert that by using the assert throws method. The first parameter is the class of the exception that we are expecting, and the action is the second method. So this is typically a method call that should generate this exception. If the exception of this type is thrown when this method executes, the assertion passes, otherwise it fails. As I've mentioned already, each test should have its own isolated universe, which means that each test is completely independent of all the other tests. Therefore, each test should create its own test environment. Because it is isolated, it means that no other test can influence the outcome of this test, and no test depends on the result of another test. It's important that each test should test only one thing. I've put thing in double quotes here because thing is a bit of a vague term. We're talking more so about concepts. We're testing one concept, and that might mean that we have multiple assertions within the test. If you're using test-driven development, then typically you would aim to have just one assertion per test. But if you're writing a test for code that already exists, then you might consider having multiple assertions in a test. But I'm not terribly in favor of that, because if you have multiple assertions and one of them fails, it means that the other assertions that follow will not get tested. And I think it's a much better idea to separate all the assertions into a test of their own, so that as much information about the success or failure of a piece of code can be determined in one execution of the tests. When we're using JUnit, there's this test cycle that we would go through. Before and after changing the code, we would run the test suite. Then, for each test that fails, we will consider first, is the test wrong? If it is, correct the test, and then run the test suite again. If the test is fine, then the problem is in the code that we're testing, in which case we need to correct that code that is under test, and then we run the tests again. And because we're using an automated framework, those tests will run in the same way every single time we run the suite. And that means that testing has become easier. We can run thousands of tests in a relatively short time. We can see the result very, very easily, and we're using the same data with every test. And that means testing has become consistent, which is very desirable. Here's an example of a JUnit test. The actual code here isn't terribly important. I just want to give you an idea of the structure of a test. First of all, we're setting up, through the creation of objects and things that we need, the test's universe. The test is not relying on anything else that happens to have been created elsewhere. We're creating everything that we need for this test inside the test. Having created everything we need, we can then set the expected result. This is what we expect the result of the action to be. Then we take the action, so we're calling a method to achieve some kind of result. And then finally we assert, so we're testing the result of the action. So we're asserting that the actual result is equal to the expected result. And that assertion, if it passes, means that the whole test will pass, and if the assertion fails, the test will fail. This four-step approach is typical of a test. Create the test's universe, set the expected result, take some action, and then test the result of the action. There's a lot of additional information to be found on the internet and elsewhere, and so I recommend that you do some background reading on some of these things.